For this video, we are going to illustrate cluster points of a given set. Or in short, I'll be providing you with a set, and later on we're going to identify the cluster points of the given set. Let us start with set A here being the interval 0 to 1. Let us identify the cluster points of this given set. Take note that a cluster point, point C, may not be an element of this, may also be an element, such that if we could locate a delta neighborhood, say for example, this is our interval, let's say 0 and 1. If we could locate here any C, where C is an element of real numbers, and then for any delta, okay, this is minus delta, this is plus delta. If we could locate here element X not equal to C, but an element of A, that means C is a cluster point. Now, for this given set, every point in the interval 0 and 1, okay, is a cluster point of A. Here is the discussion or explanation. Okay, let's start with the endpoints. 0, at 0 here, okay, even if 0 is not part of the set or the interval, for how no matter how small delta is, very small delta, plus delta, and minus delta, and that would be its location here, okay, there exists an element in this case, this one here, an X here, such that the distance of that X and C, in this case 0, okay, is still less than delta itself, okay, and that X is still part of our interval here. No, it doesn't matter if there are points not outside of A. The point here is if we could locate an element of A with the distance of from C, which is less than delta, and that means 0 is considered. This is also true with the understanding of picking here C being equal to 1, because no matter how small delta is, there is still a part of an element here, an X, where the distance of that from C, which is 1, is less than delta. Okay, now of course all the inputs inside here, let's say for example this one here, no matter how small, there is at least, that's the point here, at least one point in that is not equal to C, okay, but an element of A. That means all of the entries here are also cluster points. So in this case, for an open interval, we have here the closed interval 0 and 1. Let us have another example, and this time let's consider this set. We have the set containing 1, 2, 3, and 4. What are the cluster points, or is 1, 2, 3, and 4 a cluster point of set B? Now, if we're going to have here a real number line, we have here 1, 2, 3, and 4. If we're going to pick here 1 as our C, okay, and if you're going to have here delta, no matter how small it is, okay, so that would mean that would be this case, this is delta. We can find here a point on a real number line. Let's say this is our X sub 1 and X sub 2. Yes, they can be elements of real number. However, strictly for our cluster point, our C must be an element of A. However, this X sub 1 and X sub 2, even if it could fit the idea that the distance of that from C is less than delta, these two, X sub 1 and X sub 2, okay, X sub 1, X sub 2, are non-elements of A, because X that would fit the criteria must be an element of A. It may not be, our cluster point C may or may not be an element of A as long as it's real number. However, it's very strict that X should be an element of A. This is also true for 2, 3, and 4. This is because this is a finite set. When you say a finite set, all the points in that finite set are not considered to be cluster points. That would mean here there is no cluster point. Of course, the points here in the middle are non-elements of B. I'm sorry. This is B, because I am using B here. Of course, these points here are element of B, but non-elements of B. So we cannot actually use that because, again, the excess that should be considered must be element of B first. Now, let's have another example. Let's say C is the set containing 0 and 1 union with 2. That would mean in the real number line, we have here 0, 1, 2. This is open, okay? And this is 2 here. What are the cluster points of this? So, when you look at this interval, this is similar to the first one here. The first one, that would mean cluster points include the closed interval 0 and 1. Okay, because it would include everything here and the endpoints 0 and 1. The question now here is 2 also a cluster point? Now, since 2 works the same as this finite entries here, as they are only the point in this real number line, again, no matter how small delta is, minus delta plus delta, okay, and you would find here, say for example, x sub 1 and x sub 2. They are first and foremost non-elements of set C. So even if they fit the criteria, so they 2 cannot be part of our cluster point. So only this is considered. Now let's have the last example here for this group. We will have a separate video for more intriguing examples later. What if our set is defined as this one? Let us have here 1, the open interval 1 to 5 less 3. This would mean in this real number line, we have 1 here, 5 here, of course 3 is here, but this is open as the 3 is not included. Okay. Does it work the same as letter C? Well, the first part is true for the cluster point or points. Again, it will be the interval 1 to 5 because again, all of these are included here. Now, how about this 3 here? Earlier, our 2 is not part of the interval. It's outside the interval. Hence, the idea of similar to that is applied, hence 2 is not included. However, here 3, even if we subtract that 3, it is not part of the set. Now, if we're going to consider this as our C and locate delta, so minus delta plus delta, okay, we could find here x sub 1 and x sub 2, which falls on the same set because f sub 1 based on the figure and x sub 2 are elements of set D. Okay? So they are elements of set D, and it follows that the distance from that to our C, which is 3, fits the criteria that it's actually less than, or a definition, less than this one. X minus C must be less than delta. This fits the criteria as well as this. So should we include C as a cluster point even if it's open? The point here is even if 3 is not part of our set, just like what happened here first, 0 and 1 are not part of the set, but because there exists a certain C, no matter how small the delta is, it fits the criteria, we include 0 and 1. And since here, the same thing will go, even if 3 is not included, it's open, so it should be open for a while. It should be open, my bad. This is open, okay, open. There exists, what do you call this one, X in the delta neighborhood that fits the criteria. This would mean 3 being part of the interval itself is included. So that means included 3. So we will not be removing 3, but we include that because it's part of the interval. Unlike earlier 2, which is outside the coverage of the interval. So this is how we identify cluster points of a given set. And we'll have more examples on the next video. Thank you very much for watching.